In this section, we're going to be talking about loops in JavaScript. These are also known as iterations. So if we go to our JavaScript reference on our reference page, if you scroll down, there's an iterations section. And this shows the different types of loops that are supported in JavaScript. The most popular are our for loop and our for in loop. So looking at the for loop, it's pretty straightforward. The syntax, you have an initialization section separated by a semicolon, and then a condition which tells you when the loop will stop, and then your final expression, which is what I think of as your incrementer. So at the example, for our initialization, we initialize a variable I to 0, and then the condition is that I is less than 9. And then for our final expression, we are incrementing I by 1 each time. So it's going to start at 0. The next time it runs, it'll be 1. Next time it runs, it'll be 2, and so forth. And for the body of the loop, we have a code block, curly braces, and we are just creating a string, which is each successive value of I. And you can see the expected output, 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can just copy this and do a quick example in TIA. So I'll add a button, and for my text property, I'll do a for loop, and under events, I'll open up my JavaScript code window. We're going to use our debug.write method. Item.name for our source, and then string is the output. And I'm going to add one other thing. I'll just debug.write I is equal to, just so that we can see the progression of the loop. So I'll save this and just go check it out in Runtime. So we'll open the debug window, and that's about what we expect. For each execution of the loop, I is incremented by 1, and then after the loop, we print out the string that was built, which is just the digits 0 through 8. So that was a simple example of a for loop. Let's take a look at something a little more useful. Loops are really good at traversing a list of items so that you can select the ones that you're interested in. And we've been working with a couple of collections. One collection is the tags collection, which gives us a list of all the tags. And another is the screen.items list, which gives us a list of all the items on a screen. If we go to one of the references for this section, the Semantic WinCC Unified Tips and Tricks, it's got a lot of very interesting things in it. And if we go to section 5 in the table of contents, they have tips and tricks for scripting WinCC Unified specific. And if you go through these, there's a lot of useful examples in here. And one of these is counting screen objects and finding screen object names. So if we go to that, it's on page 44. They give you a quick script to find out how many items are on the page. So I am just going to copy this and go back to the software. So let's do an example where we find out how many items are on the page and then loop through them and just print out the name. So I'll just grab a button, and on the text, I'll just write loop screen items. And we'll go to our JavaScript interface here. And I'm going to paste in the code example from the tips and tricks. And let's take a look at that. So what we're doing is we're creating a constant that gets the list of screen items. And then they are just tracing out the count. Well, we don't have to use trace. We have something far more useful. So let's just do debug.write and then item.name, which is the name of our button. And we'll just print out the message total objects for this screen is, and we'll do our plus, and then we'll just get the count, and then I'll put my period here. So let's just take a look at this in runtime really quick and make sure it works. So we'll go to our scripting page, throw up a debug window, and it did give us that there are 32 objects. We could count those, but that seems reasonable. So we'll go back, and now we will do our for loop. Since we know where to stop, then it kind of makes this easy. And if we go to snippets, we can just do snippets logic and just do a for loop, and it gives us the body and everything. Also, it sets a variable for our 0, and so we'll just replace this count with items.count. So we're going to go from 0 to the number of items on the screen. We're going to increment by 1, and then we're going to print out the name, and they've given us a comment, print out name of each object. And we will use our debug.write, and this is the name of the button that we're on. How do we access which screen item we're on? Well, when you do screen items, you can do screen items and give it a name to get that particular named object, or you can put in a number. So in this case, we can just do items I, which is our number, .name, and that will print these out in order of the number that they're in. So let's save this and check it out in runtime. Okay, so in runtime we'll go to our JavaScripting page, open the debug window, and we have 32 objects, and then it lists all the names of the objects that we have on this page. Pretty simple. So going back to the tips and tricks scripting guide, where we got the item count example code, if you notice below that, they actually have a for in loop that is doing basically what we're doing. It's printing out the screen item names. The for in loop is a little bit different than just the standard for loop. In the case where you have an array or a collection of objects, it's pretty simplified. So I'm just going to copy this code and go back to our Java screen, and I'll add another button. And for our text, I'll just put for in example. And we'll go to our events and put a JavaScript on our click left mouse, and I can just paste the code in. Now the for in loop uses the in keyword, and it assumes you have a collection of objects or items, and you set a variable equal to that list, and then you can access all the elements, and it will automatically stop once the end of the collection is reached. If we go back and look at the original for loop, it's different because you tell it where to start, you tell it when to stop, and you tell it how fast to go. So this is a much simpler example if you have a specialized collection. So what we'll do is we will convert the trace to our own debug write function and just say for in loop, and then we'll just print out the screen name. We do have to put in the source, so I'll just put in item.name, and it is case sensitive. So we'll just save this and check this out in runtime. So we'll go to our JavaScripting page and pull up our debug window and hit the button. And it looks pretty much the same. So basically it's two types of loops doing the same thing, and we can do that because we have this array of objects. Okay, so now I have an assignment for you. In this assignment, you're going to familiarize yourself with the TagSet object, which is basically a custom collection of tag objects. You can think of it as an array of tag objects that you create. In the TIA help system, search for Create TagSet Unified and read through the TagSet object's descriptions, methods, and properties that are in the JavaScript object model. And here's a hint, make sure you review the TagSet's read, write, and item methods, as well as the tag object's value property. These are going to help you complete your assignment. To access the help system, just go to Help, Show Help, and put in your search function. It's also very helpful to go to the visualizing process under Programming, WinCC Unified Object Model. Under Objects, you can look up your TagSet object and read about all of the methods of the TagSet and how to use them. Also take a look at the tag properties themselves, because the TagSet is just a list of tags, so all of these are valid as well. Once you familiarize yourself with the TagSet, then open your project and create 5 integer internal tags named value1 through value5. Add these to I/O fields on your JavaScript screen. Then add a button to the JavaScript screen that will do the following. Number 1, create a string array that contains all the tag names that you created earlier in step 2. If you're unfamiliar with arrays, go to your JavaScript Mozilla documentation and learn how to create a string array variable or constant. After you've created your string array, create a new tag set by creating a constant and setting it equal to a new tag set object using myTagNameArray as the initializer. You're going to be using the createTagSet method. Then call myTagSet's read method to update the tag value properties. Then write a for loop to loop through all the tags in your tag set and print each tag's current value, and then increment it by 1. After the for loop, call myTagSet's write method to write the incremented values that you stored in the value property directly to the tags in the tag set. The I/O fields on the screen should show the value tags incrementing every time you press the button. So in Runtime, you'll start out at 0, and as we execute the script, you should see them execute. If we have our debug window up, you can see that we're printing out the name and the value, and then the incremented value is written to the tags shown by the I/O fields. So go ahead and pause the video, complete the assignment, and when you come back, I'll show you how I did it. So I started off this assignment by going to the help system and reviewing the TagSet object. The things that are important to know is, what is the TagSet? What does it represent? And it represents a group of tags. And so these are indeed tag objects. So you may want to pay attention to the properties of the tag object, because for each loop, you're actually looking at a tag value. Also, your read method, which it tells you that when you call read, it's going to update the values of the tag object. And when you call the write method, it's important to know that this is writing directly to the tag, but it's pulling it from the value. So it says you must first set the values of the individual tags with the value property. This is why we do this in a loop. We update our value property. Another thing that I found is under item, which is each tag item, it says that the tag name or index number, and notice that it says 1 to n. That means that the first tag object does not start with 0, it starts with 1. This is unlike the screen items that starts with 0. So hopefully this one didn't trip you up too much. So this just underlines it's a good idea to go back and really just kind of read everything to try to understand how to use these objects. So going back to the software, the first thing I did was I created my tags, value 1, 2, 3, 4, and 5. They're all integer data types and they're all internal. Next, I opened my JavaScripting page and I just drug these directly out onto the page. And if you look at the properties of these, under your process value, you can see that they're corresponding to the tags. And I did put labels here. And then I created a button for the script. So looking at the script on the button, first I created a tag set array, and it is just an array of string values. So If you aren't familiar with arrays, the JavaScript Mozilla reference should have given you some pretty good examples of how to do this, and these just correspond exactly to the names of the tags you created. Second, we should have created a constant. I called mine myTagSet, and called the createTagSet method with the array. This creates a tag set with our value 1, 2, 3, 4, and 5 tags. Then the next thing you have to do to update the value property is to call read. It'll read the tags and update the value property. And then I just printed out my count to make sure everything looked okay. Then I created a loop. We set our initializer to 1, again, because the definition of the items collection for a tag set defines that it starts at 1 and not at 0. And the test value, or when it stops, is going to be I is less than or equal to my tag set count. And we just increment by 1. So it's going to count 1, 2, 3, 4, 5. And for each iteration of the loop, I create a variable t and set it equal to the tag object that corresponds to the number that I is. And then I do a debug write of the name and the current value. And then since t is referencing this particular tag object in the tag array, I just update the property value by 1. Now this is not writing to the tag. This is just updating the property value. After this loop completes the last line of code, we'll call the write method. And at that time, it will take whatever the value property is and write it to the respective tag. All of this information is available in the help. Sometimes it takes a little bit of trial and error. So going back to runtime, we can run the script again, and hopefully you were able to complete the assignment. So let's go back to the JavaScripting page for a moment. And if you recall, for our original loop, we did screen items using a traditional for loop. And then we did a for in loop, and we got this sample code out of the tips and tricks guide. And this seemed like a much simpler loop because we just said for let I in screen.items, and we just printed out the name. So why did we do the assignment in a regular for loop, and perhaps some of you tried to do a for in loop? So I took the liberty of creating a for in loop, and everything else is basically the same. And we just say for let I in myTagSet.items, and we print out the name, and we do the increment. So let's see what happens in runtime. So on the JavaScripting page, I'll hit the button and we immediately get an error. Now I put a try-catch block in so I wouldn't have to go to the tracer, but it says that the property get IDs of names failed property items. So basically, looking at our script, it failed right here. So in the next section, we're going to be covering debugging using the browser, and we're going to let this script wait until then, and we'll see if we can figure out what the problem is with the script and if we can get it to work. So in finishing up our section on loops and scripts, there's a few things I'd like to point out. Number one, loops take up a lot of CPU power. Long-running loops will load down your CPU and delay other scripts from running, so you should be very careful when using them. You can also have an infinite loop, one where the test case is never satisfied and therefore never stops the loop. This will eventually stop your runtime and you'll end up rebooting. Therefore, use loops sparingly of your scripts, if at all. If you can find another solution to do the same code, then do so. Also, only use loops to traverse lists or arrays which have known limits, such as a tag array. Don't use them as a delay or to wait for an event that may not happen, i.e. a tag value going to a certain value, or waiting on user input. These things may not happen or may be very delayed, causing degradation in your online performance. Looking back at our JavaScript reference, there are a few other types of loops that we didn't discuss, namely the while and the do while. The while statement and the do while statement are usually used when we know something may happen, but we don't know when. So the while loop just has an expression, and as long as the expression is true, it executes the loop. The do while loop is exactly the same, but it always guarantees to run the loop at least once because the conditional expression is at the end of the code body. The most common loops that you're going to use are going to be the for and the for in loop. But in any case, it's recommended to use loops very sparingly, as we have discussed. In the next section, we're going to look at debugging scripts and finish up the JavaScripting section of this course.